Jamie, is that you?
I'm here. Good morning, everyone. This is Jamie Smart.
Okay, hold on.
And we've got Craig Pickett with us as well. We'll be starting here in about another 15 or 20 seconds.
Can you hear me? Are we good?
Yes.
Okay, hang on.
Once again, good morning, everyone. This is Jamie Smart with Whitmix. You're here today for the Phosphate Investment Webinar, Secrets of Success. Craig Pickett is also joining us. He's actually going to be doing the presenting today. I'm just here to facilitate and answer any questions that you might have. If you're new to the GoToWebinar format, there's just a couple of things that I want to point out real quick that might help you ease some of the confusion that you may have with the webinar process. Down your where your name is, it'll say attendee list, and you'll find your name there. There's a question mark and there's a question tab. You will be able to type in questions. They can go directly to me, and as we move through the presentation, I'll pass them along to Craig as we need to, and then we'll answer any of them that we didn't get to during the presentation at the end. But you can use that tab for writing in any questions that you might have. The other thing that I want to point out is there's also an option within the GoToWebinar for raising your hand. You can actually raise your hand, and if you're having any technical issues or anything like that, feel free to use that feature. It'll just say raise your hand, and I'll know that you have your hand up, and I'll try to help you out any way that we can. If you're having any other technical difficulties outside of that, we'll do our best to try to address them as need be. So one final thing. Just because of the amount of people that we have, we are going to go ahead and mute the audience so that we don't have to worry about crinkling papers and potential interruption of that regard. So just so you know, we will have you muted. So again, please try to use some of the features that we talked about earlier, raising your hand or typing in a question. The other thing, of course, is because you are taking your time out of your day, we will be offering CE credits. When the presentation is completed, there will be an email that will go out that will have a link to a website that will guide you through the process of taking the class and taking the test for the webinar, and then also earning your sending it to us so that you can earn your CE credits for having participated today. So again, we want to thank you for joining us today. I'm going to be turning things over to Craig here shortly, just so that you'll actually be seeing his screen instead of my screen. And again, I'll be kind of monitoring the any questions or comments that you might have during the process. So at this point, without further ado, I will go ahead and get things turned over to Craig. You'll be seeing his screen now. It will take just a second for that to transfer. So if there's a brief pause, switched over. So I appreciate your joining us this morning, and I'll get things turned over to Craig. All right, Mr. Craig, you're in control.
Okay, I'm still trying to bring this up, Jamie, so I've got a little technical difficulty here. Maybe you can help me with this one over on this side of the world, and I'll kind of explain what I'm going to talk about today to the guys. Once we get it up on the screen, we're going to get flying with you here. And we're going to talk today about phosphate investments in general. We are going to use the Whitmix products, and we're going to be referring to them. Certainly you can use whichever products that you are currently using and take a look at the recommendations that they have. And then make sure that you apply them to your individual situation. The thing you need to remember consistently is that your situation is going to be slightly different than another's. There are many things that are very similar, but your circumstances, your machinery, your environment, all of that is going to affect how your investment behaves. And so you need to make sure that you take a look at those issues and apply them to your individual situation. Okay, I think we're right about there. So hopefully you should see up on your screen, it should say Phosphate Investment, Secret of Success, and we'll go ahead and march ahead with this presentation here. Here we go. All right, so first of all, there are really two different types of investments. There's gypsum and there's phosphate. The gypsum investments were indicated for low fusing crown and bridge alloys, and those of you that have been at this quite a while probably use some of the old ones. Beauty Cast being probably the most prevalent one from the Whitmix Corporation. You didn't need any special liquids. Most of them were standard burnout technique. You'll notice also something that says a hygroscopic technique. Some of you might even have an old hygrobath laying around the lab somewhere. Most of these gypsum investments were designed as inlay investments. They had very little expansion. And when we got to doing full cast crowns and liked the behavior and the surface of the gypsum, but had problems with the expansion, we had to come up with a way to drive expansion. That was a hygrobath, or a constant temperature water bath that was applied during the setting process, and that drove the expansion. Most gypsum investments can only be used for standard burnout techniques, so if you're not doing that, you're being successful. Congratulations, but I'm worried about you. Unless, of course, that particular gypsum product has stated that you can use a rapid style burnout. Now, we came along later with phosphates because we needed higher temperatures. And phosphate investments now can be applied to all alloys. You will get some variation in surface and some differences in finishing technique because you're not working with gypsums, especially if you are switching from a gypsum alloy to a phosphate alloy. You'll notice some of those differences. You will need to use special liquids, and you can use a rapid or a standard burnout technique. Now, many people have asked us why there are so many Whitmix investments. You'll notice on the left, those are the gypsum investments that we produced, and on the right, those are the phosphates that we produce. And really the answer to that question, which is why are so many, is because Whitmix has been doing this for 93 years. And we've responded to the market. As the market has changed, as laboratory technology has changed, We've come along with newer products and that meet the needs of that change, and yet at the same time, technicians that are still doing older techniques wanted to keep the materials that they had. So we have discontinued some of them across the years that some of you older technicians might remember, when demand became so low that it made no sense to continue manufacturing. But you'll notice that you have a lot to choose from, and so we need to talk a little bit about choosing. These are really the questions you need to ask yourself. Am I going to be casting with standard cast techniques using alloys, or am I going to be pressing? Am I going to be using this to press? Am I going to use rapid or standard burnout procedure, or do I need to use both? And if I am casting alloys, what kind of alloy am I going to use? All of the answers to those questions are going to determine which investment you use successfully. And so you need to be answering them just as precisely as you possibly can. Now, most of us are turning towards what are referred to as universal investments, those that can be used for everything at this point in time. And if you're using a truly universal investment, you'll be able to use it for any of these procedures that you see. Now, investing process is science. It's not cooking. And unfortunately, we kind of have this little bit of wishy-washiness as technicians, a little lack of exactness many times, and we think we can kind of do things the way that feels right. Okay? But if you look at some of the cooking shows on TV, every once in a while you'll see them, they'll pick a pinch of this and a dash of that. We can't be doing that when we're doing investing procedures. We've got to be specific, or we will not get the end result that we're looking for. There's an old scientific adage, every action has an opposite but equal reaction. This is absolutely true. How does that apply to us? Well, you can't change one thing without changing another. So every change that you make is going to affect something else, and you should be prepared for those changes. Everything is interrelated in the processes that we're involved in. Okay, so let's talk about some issues that affect your investment. The biggest one out there is temperature and humidity. This is constantly changing. Temperature always changes. Humidity always changes. Even if you're in air-conditioned or heated facilities, your humidity is still going to be changing depending upon the time of the year. Those that have taken a bit of chemistry previously recognize that if you heat something up, a reaction will happen faster. If you cool something down, then the reaction happens slower. As people, we're kind of a little bit like that. It gets colder in the winter. We have a tendency to creep along a little bit. Notice, too, that the humidity is a factor here. As moisture increases in the air around us, then it changes the reaction. As the moisture dries out in the air around us, it also changes the reaction. So these are three good things to try your best to control in your laboratory environment. Now, many of us also have automated heating systems and cooling systems, and we're on thermostatic controls that are computer controlled now. They shut down a little bit or cool the building off in the evening and then kick the heat on, or vice versa, depending upon the weather. Now, that's going to make the air temperature feel good to you as you come in. But if your laboratory is cooled off during the middle of the winter overnight, then so have all of your benches, your chairs, your equipment, and all of the powdered product materials that you have, the liquids, everything else, the drawers, they've all cooled down. And they will not come back up to temperature as quickly as the air surrounding them. So you're going to have to take that into consideration as you go through temperature changes in the atmosphere in your particular geographic location. Now, there are three types of expansion that we need to concern ourselves with. Two of them you're very familiar with, and one, it's probably maybe 50-50. Some of you are and some of you aren't. and haven't thought of it before. The first one, of course, is setting expansion. This is the expansion takes place while the investment is setting up on your bench. The second one is wax pattern expansion, which is something that you're maybe not as familiar with. And the third is thermal expansion, and we're going to talk about all three of these. The first thing is setting. Now, this is the expansion that takes place from the chemical reaction of the liquid and powder and mixing. All phosphate-bonded investments have a certain amount of setting expansion that's built into them by the chemists that created these formulas. And depending upon the investment, you'll find them on the market anywhere from 0.5% to, or excuse me, 0.5% to 3.7% in expansion, which is quite large. This particular little card here is Formula 1. You'll notice in the top right-hand corner there's a physical properties box. We will tell you what the setting expansion is. Now for Formula 1, it's 1.6%. And you'll notice that the thermal expansion, which we'll get to just in a minute, is 0.65%. All the manufacturers should have this physical property information for you. If you're trying to get greater expansion than the sum total of these three in any particular investment, then you're going to need to make some changes either in the investment that you're using to get one that gives you a higher expansion, or perhaps in the liquid that you use. All right, now with that, correct ratios are very important. Changing the ratios changes the expansion. Now with that said, the next question has to be asked, how accurate are you? Historically, we've used graduated cylinders, and we've used powder measures and weights, and some of us have even gotten away from that perhaps and just know how it should be or know how it feels. Those of you who are still using graduated cylinders, you should be filling that material, the liquid in that cylinder to a specific line, but the question is it the top or the bottom of the meniscus that you measure to? Now, if that's a question that you have in your mind, you need to answer that question, or I'll answer that question for you. It is the bottom of the meniscus. So if you're measuring to the top, you're already short in your measurement. So we need to know those kinds of things right off the bat. And it may be part of the problem that you're having is that because you're measuring incorrectly, you have differences in the chemistry. Now, there are advanced dispensing technology equipment that is available on the market. This is the AquaSpense from the Whitmix Corporation. We have two versions of this. One is simply a water dispenser for use in your model and die department and working with gypsum model and die stones and plasters. The second is the AquaSpense SL. This particular machine will dispense water and special liquid concentrates, that special liquid that's used in phosphate investments. You're capable with means of putting in the exact ratios that you want, having them dispensed exactly every single time based on the weight of the powder that you've put on the scale. This makes you very accurate and very consistent, which is important in your investing procedures. Now, liquids are colloidal silica. No matter whose company you buy phosphate investments from, the liquid that you receive is colloidal silica. Now, there are variations in the concentration of the colloidal silica that comes in the bottle. You've actually seen some that are a little different colored. Some are colored pink. Some have a light yellow color to them. That, in general, is an additive. The yellow is, for some colloidals, is very much a natural color. The pink is not, and is added to it for that individual manufacturer. These liquids are used to help control expansion. Now, they come in either freeze or non-freeze stable varieties. The liquids that you see on your screen right now are the 4 liquids that are available at Whitmix. Most of you are familiar with special liquid concentrate. We did have a change this last year. We combined the names of the products that we were using so that there would simply be 4 for you to choose from. And we also removed them from the packaging. And we did this intentionally to help our laboratories. Some of you don't want to think about it. You just want to order a box of investment and have it come. But on the other hand, many of you have liquid bottles sitting on your shelves that you didn't use. And then you get the packages that are mailed to you in the winter. The liquid freezes. You have to just throw away that liquid that you just purchased. It didn't make sense to do it that way. So we've combined this into special liquid concentrate plus, fast fire liquid, and a liquid that we use for an international product that we call special liquid concentrate max. Now, you need to be looking for crystallization in the bottom of your bottle. If that liquid starts to crystallize, the crystals will form. They'll be large enough that you can actually rattle them around inside the bottle. If that's going on, then that bottle of liquid should be discarded and replaced. We have 1 or 2 that are freeze stable. One of those examples is the fast fire liquid that's used with fast fire 15. And what that means to you is that if this material gets to the point where it does freeze, it will reconstitute. Now, most of you are familiar with freezing milk. If you freeze milk, it separates. The water freezes up first, the solids go out, freeze second, and then it's really difficult to get it to reconstitute. It's never quite the same. And the same goes with those liquids that are non-freeze stable liquids. And so it's wise to order them right about this time of the year. The end of September, the first and middle of October, before you're in a position where weather is freezing across the country. Think about what your need will be through the winter and order in the liquid. Then the powder can be ordered separately as you need it. All right, now correct mixing is very important. You need to follow the manufacturer directions because it will change the chemistry that's involved in your investment. If you reduce the mixing time, you will get less expansion. If you increase the time, it can increase the expansion, but it also can reduce the working time. And also, if you mix too long, may cause a breakdown of the investment. Remember, as you're mixing things, you're also adding friction temperature and energy to this mix. And those factors have all been balanced by our chemists here at Whipmix so that you can have a good, consistent mix if you follow the instructions. Now, if you deviate from those, then you really need to talk to somebody in technical support here so that we can talk about problems that might arise by deviation. Or if you're not getting the results that you need, then you need to talk to us also, and let's see if we can correct some of that. Automatic mixing has come along in the last few years. This is the VPM2, which is a programmable vacuum mixing machine from the Whipmix Corporation. This allows you to push a button and walk away and save some time. Many of you are using our old mixers, which are still good workhorse units. However, if I can use the example of Formula One phosphate investment needs to be mixed for 2 minutes. Now, unless you're watching a timer, the chances are real good that you're going to either mix short or mix long on that 2 minutes. And either way, standing there holding a bowl, doing nothing more than that for 2 minutes, however many times a day you do it, is sort of a waste of time. So the advent of these new programmable machines that simply take in the mixing process for you gives you more time in your laboratory to do other processes. This particular unit will retain 30 programs. It's pretty much maintenance-free. There's no oil that you have to mess with. And there are the standard type mixing bowls that we have used for many years. This is a great way to go to produce consistent types of investment procedures. Now, let's get back to thermal expansion. Thermal is the one that goes, that happens during the heating phase inside your burnout oven. Now, during that point in time, the pattern cavity expands. It becomes larger to allow for the expanded metal or the expanded glass that's going to fill that cavity. And this expansion is controlled by the chemistry of the investment and, of course, by the temperature of the oven. Now, the one that we don't talk a lot about is wax pattern expansion. While your investment is setting up, it creates an exothermic reaction, and it develops about 180 to 183 degrees of Fahrenheit of temperature that comes off of the reaction. Now, you all have witnessed this. You've picked up the rings before. The rings are hot. They got there by themselves. This is that exothermic reaction. As this material is heating up, it transfers heat to the wax pattern also. This transfer takes place before the material hardens. And so the wax expands in soft investment and becomes larger. Now, this causes patterns to change their size, and that includes bridge work, which often can be the problem with the bridge that the copings fit, but the entire bridge doesn't fit. Many times this is because of the expansion that takes place in the mass of wax that's in your bridge. And we can adjust for that in the investment by doing a tricky kind of a thing that we'll talk about here in a little bit. Now, if you have a hard time wrapping your head around that, there's a good, easy way to test for that, because different waxes have different melting ranges, not melting points, but ranges, and expand different amounts of expansion. What you can do, especially those of you who are in larger laboratories that may be experiencing some problematic things with expansion, go ahead and get every one of your waxers to wax you up a coping on a standard die using the wax they use. Now, some of you have standardized wax. That's good. If you don't, and many don't, because waxers are kind of unique and like to work with the properties that are there that take care of stackability and carvability and crack resistance and that kind of thing. And so you'll have multiple waxers with multiple waxes. Have them all create a coping on the same die. Then sprue all of those copings up and invest them in the same ring. Then burn them out and cast them out of an alloy. Then go back to your original standard die, that same die that all the waxers waxed up on, and take a look at the differences in the sizes of the coping. This size alone can be accounted for by wax expansion, not by the investment, because all were invested in the same ring with the same investment under the same condition. For you larger laboratories, this might lead you to saying we've got to be more consistent with our wax. And in fact, I would do exactly that. Use a single wax, tipping wax for this procedure, regardless of the wax. Regardless of the waxer. All right, now let's talk a little bit about expansion. This is always a question. It gets a little confusing sometimes. So we're going to first talk about increasing expansion. To do that, we're going to increase the liquid concentration ratio in the liquid to powder, or excuse me, in the liquid to water ratio. You see, everybody gets confused. The liquid to water ratio. Now, if we look at this, the maximum setting expansion of your particular investment is achieved by using 100% straight liquid, no water added. Now, if we look at the example on the right-hand side of your screen, 18 milliliters of special liquid plus 2 milliliters of water, if we've used that, let's say that's your normal expansion. That's the one that you like. But you realize that something's fitting a little too tight and you need to increase the expansion. So you would step up. Here's the example, 20 milliliters of the special liquid concentrate with no water added. This will give you higher expansion. Now, during this process, you want to keep the same liquid, total liquid to powder ratio. Don't change that. All right? Now, also to increase expansion, you can warm the liquid or the powder and the bowl, and this will affect your working time slightly, of course. It'll extend it a little bit, but you'll also get a little bit more expansion if that's what you're looking for. Now, my personal preference is to warm the powder. There's greater mass in the powder than there is in the liquid, and therefore is going to retain the heat longer. If you just warm your liquid up and pour it into cold powder, the heat's going to dissipate quickly and not affect the reaction very well. So I would stick with the powder or both, or all three. Now you can also increase your mixing time by about 15 to 30 seconds, and that will help drive the expansion a little higher. But you don't want to overmix. All right, now let's look at reducing expansion. Let's say you've got the one that's the socks on a rooster, as a lot of the technicians refer to it. What we're going to do is we're going to reduce the liquid to water ratio, always keeping the same total liquid to powder ratio. Here's the example of normal again, 18 milliliters of the special liquid and 2 water for a 20 milliliter total. If we want to reduce the expansion, we would drop it, let's say, to 15 milliliters of the special liquid with 5 water, so that our total is still 20 milliliters for our powder. Now, the other thing that we can do also is we can cool the powder or the liquid. A lot of folks will refrigerate them to bring down the expansion. Or we can also reduce the mixing time. Now, when we reduce mix time, we have to be very careful, because part of that mix time is there to incorporate the chemistry that's in the powder and the liquid. It's not just about getting the powder wet. It's literally about dissolving components that are in there. And so you don't want to reduce your mixing time more than 15 to 30 seconds, or you could be in a problem area. All right, now for just a moment, let's talk about the geometric center principles. These are very important because they will change what happens to your alloy once it gets into the investment. A lot of problems are blamed on the investment when often it is a problem with the geometric center principle. All right, the geometric center is the last place in the ring to cool down after the metal's been cast, and that is just about exactly the center of a ring, as you can see drawn here on the screen. But it can change, and let's talk about that. The investment, for example, that surrounds the crucible former down at the bottom doesn't have much mass to it. It's very likely that it won't contribute significantly to what's going on in the center of the ring. And so the center of mass becomes the true heat zone. This is probably a better indicator, this picture that you see on your screen. This would be our center of mass. This would be also the center of heat, that area which is going to retain the heat the longest. Now, if we talk about placement, place our rings and our patterns appropriately inside that center of mass so that the heat is controlled. And we control what happens with the temperature in there and its application to our patterns or our casting that's just been made. Here's a good example of one on the right-hand side that has been centered properly with a runner bar, sufficient alloy, everything is squared away the right way. All right, but let's talk about what happens when you cast too large of a button. Now the amount of metal in there changes or shifts the heat center. You have this mass of metal that's retaining heat and competing with the connector bar to be the reservoir. And you will see by the little H in the center that it shifts the heat zone down toward the button. Now, on the other hand, if you cast one that has no button at all, using a small runner bar, then the chances of the heat zone moving up into the mass that was there with your wax patterns is very likely. That gives us the heat in the wrong place. We get solidification of the runner bar prior to the time that our patterns solidify, and porosity is the result. So we want to make sure that we're not casting too large a button, that we have our center of mass in the right relationship with our patterns, and the best relationship to think of is that the patterns need to be high and outside, little baseball term. They need to be high in the ring and to the outside of the ring. That will get them into the area which is coolest or cools off the most quickly, and we'll get the alloy or the glass solidified there first, prior to the time that the bar or the sprues or the button solidified. Here are two examples. On the left, you're going to see one that was too little alloy, too short sprues. These are the guys that are still using that little tiny 60-gram ring because they think they're saving money on investment, and they're having problems with casting. This is just built wrong. There's too many patterns in that small a ring. There's not enough extension on their sprues, and the patterns wind up right smack in the middle of that heat zone and cool incorrectly. You can see that this one actually caused problems with the surface of those particular patterns. Now on the right-hand side, you'll see a fairly large button, but compared to the mass of the material that is in our patterns, we're pretty well balanced. And we have nice sprues, and you can see from the surface of the sprues and the surface of the patterns that this casting went very well. It was planned out well in the ring. All right, now let's talk a little bit about spruing techniques. First, there's direct spruing, and here's an example in the picture. You want to try to cast smaller buttons, and this will help prevent premature cooling of the heat center, or that center of mass, and it will help also to prevent the sprue lead and the button from drawing metal back away from your crown, which gives us that porosity that we want to escape from. Make sure that you're connecting your sprue to the thickest portion of the restoration in relationship to those axial walls, and in this case, on this upper, you'll see that that would actually be on that mesiolingual cusp. This is the area that's the thickest. All right, now you also want to ensure smooth connections. We want to reduce the turbulence that the alloy or the glass encounters. And so those connections need to be, and movements need to be nice and smooth, so that the entrance to that mold, especially with alloy, is nice and smooth. Sometimes if you're not careful about making that little connection smooth, you actually wind up with small pieces of investment hanging there after the wax has been burned out, and then as the metal mass flies into this mold, it breaks them off. And they have a tendency to travel to one place and one place only, and that's the margin. So make sure that those areas are nice and smooth as you enter into the molds. All right, now you've seen this kind of porosity before. This is probably the most common error of direct spruing, suck back porosity. This is a button too large. You can see how large this particular one is in those fingertips, and a sprue that's too short. And that pulled, as this cooled, the material was pulled back away from the crown and resulted in this nice hole. None of us like to try and solder. Not as nice a restoration. All right, here's another good example of incorrect placement. If you look where these arrows are pointing, you can see porosity all through this alloy. This was placed wrong in the heat zone. You'll notice we have patterns all over the place. If you were to turn this and look at it from the side, you could see that those in the center are higher in the zone. Those on the outside are lower in the zone. You also have multiple units that are stacked up, so you've got a lot of metal mass going on there. And if you look very carefully, you'll notice that there's sort of a green color to the whole thing. This happens when we use non-precious alloys repeatedly. We shouldn't be doing that. NP alloys, unless they're specifically designated, are one-time use alloys. When you use them over and over again, they burn up those trace elements that are in them, and they produce poor quality alloy, which will then translate to problems in your ceramics. Make sure that you're not doing that. You also have this massive amount of metal that's been cast as part of the indirect sprue system, or the runner bars that are under there, and the button at the bottom, which changes based on what we talked about in the heat zone, changes how this alloy solidifies. So pay attention to those kinds of things as you're setting up for spruing, and as you take a look at the placement of those sprued units inside of your ring. This is a good example. These were dummy castings, solid, full casts, and you'll see that they all came out very well. Not a very large button at the bottom, plenty of sprue. You'll notice even on the right-hand side where we did get some shrink or suck back porosity in the sprue itself, but that's a good place for it. We don't really mind having it there, as long as it's not in our units that we're trying to cast. All right, now some tips on the indirect spruing. Runner bars should always be as thick as the thickest part of the restoration. Runner bars do come in various sizes, and so you don't want to over or underkill that runner bar. Make sure it's appropriate. And you want to err if you do on the large side for the runner bar, but you don't want to be overly massive. The restoration should come off of the top of the runner bar, but also be angled toward the outside of the ring to get away from the heat center. If you stand them straight up and down on your runner bar, you're going to have problems, and we'll show you some of those in a minute. All right, now also you can do direct spruing. Indirect spruing does, however, offer us some advantages. You get a little greater predictability, some reliability there, because you do have a reservoir. Now, we do have reservoir sprues that are on the market also, and they're good to use in our single cast. You also get greater control of sequential cooling because you do have the reservoir. And then, of course, prefabrication in sprues offers a little bit of a time saving. And there are different sprues that are on the market, but take a look at the ones that you have. If they're solid plastic, that might be problematic. If they're hollow plastic, you probably can get away with that. I had good success with those that were from the Diequip Corporation over the years. But take a look at your spruing system and see if that's contributing to any of the problems that are out there. If you're making your own custom sprues or custom bars, or you're taking and changing a prefabricated wax bar, remember that wax has memory. Now, on the left-hand side, we took a standard wax runner bar. We warmed it up. We bent it into the shape we needed. We added a little bit of wax just so you could see that it was fluted to the right-hand side and then touching on the left. As the bar material cooled, the picture on the right shows you it shrinks. That memory, that trying to return to its original position, may very well be causing you to have problems with bridge work that you've set now on one of these bars. As it moves back into its, or tries to move back into its original position, it's putting pressure on your wax up and could possibly be flexing your bridge. So make sure that if you're using these, you bend them into shape and then set them out, let them cool off to room temperature before. All right, now we've used plastic runner bars for many years. We started way back in the 80s. We used to cut off sections of runner bar like this that we bought at local plastic stores. And then we started having all kinds of problems with cracking and thinning, and we couldn't figure out what was going on. We realized eventually that plastic had its own properties which were working against us. And we'll show you those in just a second here. This is how we did it back then, and if you're still doing this, and having any issues with thinning around the bar or other areas, you might want to consider just simply coating that plastic bar with a little bit of wax. That will help the process. Or you also are going to have to go back to a slow or a multi-stage burnout procedure. Now, as we talk about plastics, we take a look at this piece of runner bar just beginning to heat up, and you'll see what's going on in there. The plastic is not only expanding and putting pressure against your the walls of your investment, but also gases are forming that need to be eliminated prior to casting or pressing. And so this leads us on to many of the new millable type materials that we're calling millable waxes. They're really not wax. They are a resin-based material and present issues with burnout procedure and causing cracks. The greatest thing that you can do is to increase the distance between your patterns and not place so many in your ring. That will increase the thickness of the investment and give it a little more added strength. You can't coat those things with wax to get away with it, nor can you coat plastic implant parts. They're going to be problematic. So since they do have small or fine features to them, especially UCLAs, where you need to run investment through a center hole, that becomes much like, for those of you who have basements, much like that little tiny pole that's standing there in the middle of your basement in a gigantic room. That's what it looks like when those little UCLA abutments are burned out. You got a little tiny pole of investment hanging there, and you got a mass of metal starting to fly in there and smack that pole. In that case, what we want to do is reduce the velocity of the casting and also make sure that we enter in a direction that's not going to run directly into that little piece of investment. But in the case of our other plastic patterns, if we simply increase the space between patterns, we've helped to prevent some of the problems that you see. Remember, you can always add a larger sprue to a ponic. That will help to reduce the amount of turbulence in the metal that's moving through there, or possibly glass, and give you a better casting or pressing. Now, we talked a bit about too many units in one ring too close together. Now, the other thing that happens is if they're all in one plane, that mass of wax in one place is going to try to expand in one place, and generally in one or two directions, and can cause cracking in between. So make sure that you've got enough distance in between your units, or that you vary the height in your sprues. That's another good one to just to give you some more transition so that there's not that mass all in one horizontal or vertical plane. You want to ensure that you've got 3 to 4 millimeters of investment at a minimum, support between units, and 8 to 10 of investment from the edge of the ring to the runner bar, and also over the top of your patterns. You don't want excessive amounts over the top, or you want too little. So that 8 to 10 is about correct. That's the old 1/4 inch for those of you who are still in the U.S. system. Now, why is it important? It's important when the thermal and the wax expansion occurs that we don't get cracking. When there's insufficient support between the units, then the investment can crack, and this is what we get. We start getting fins that look like this. They're almost always in that vertical plane, or the plane in which there's the greatest amount of wax, either vertically or horizontally. So you want to be aware of that, and then vary your patterns. You can see in this particular case how close, how tiny the sprues are. Little tiny, less than 1/4 of an inch, most of them, puts this whole mass of wax too close together. They need to be extended a little bit. You can see the same thing is going on here, a little different casting, but that same finning routine. They're fairly close together and fairly short sprues. Just extending the sprues alone would have fixed this problem. And having one sprue taller than the next one would have fixed it even better by giving you variation. and more support of your investment in between. This is a technician problem. It's not an investment problem. Okay, now some people have even done this. Some of you are, I'm sure, gasping at this point. Some of you are going, yeah, that's exactly right. But unfortunately, if you're not monitoring where the mass of wax is, in this case in a horizontal plane, this could be the result that you get. There's just too much wax there. It all expands, cracks that investment prior to the time it ever gets hard, and then you get this monster fin that you try to recover from. We don't want you to do that. It's just too much work. So let's change and do things correctly. All right, this is a problem too, stacking these like Lincoln logs. Now these are all over the place. The big deal on this too is that it's bridge work, and so you've got the bridges in the center of your ring that are in that heat zone and are going to retain heat longest. You've got bridges that are not, that are down lower, that were just kind of snuck in, and you've got some that are going different directions. This just doesn't work out well, and generally leads to having one or more of the bridges that were put in this ring have some kind of distortion that we scratch our heads about because others in the ring work just fine. And generally that's not because of the investment, but it's because of the placement, the pattern placement. So we need to get back to good pattern placement principles. Now here's a good correct placement. All these bridges are positioned high and to the outside of the ring. This is going to allow them to cool sequentially as they should and give you better casting. There's some more good examples of pattern placement in the rings. You'll notice that the bridges are to the outside, and even the single units down to the lower left and the bottom of your screen there, you'll see are not directly in the center of the ring. They've been placed to the outside of the ring. This will give you better cooling of that pattern. Now let's talk a minute just about investing itself. You want to use either low or no vibration. If you have to use a bunch of vibration to get things to move, you run the risk of breaking patterns off, fracturing them at the connector of their sprue. You also have to worry about distortion depending upon how you invest. My preference is to fill the ring to the bottom of your patterns first. And then using low vibration and a small brush or an instrument or even a piece of spool wax, pick the investment up and place it and let it roll to the inside of your individual coping. Then come back and continue to fill the remainder on low vibration. This does a couple of things. Now I know that some of you prefer to invest the insides of your patterns first, but what that does is put a heavy ball on the top of a long stick. It's going to move even greater with the vibration that you have and could cause distortion or fracture. So this is why my preference is to do it this way. We still get the investment into the copings while the material is thin enough to do so, and they're supported by the rest of the investment that's around the base. And remember, you're going to fill to approximately 10 millimeters over the top of the patterns. Don't overfill them. This can cause blow-offs later. All right, burnout procedures. Before you burn out, you want to follow the manufacturer's guidelines. If you decide that you're going to change your burnout procedure, or you've been doing it a certain way forever but you're having problems, it might be that you need to go back to the manufacturer's recommendation. If you're going to leave it overnight, a plastic bag might not be sufficient to retain the moisture, and in many cases it's just not even important anymore. I know a lot of us have done that. Why? Well, we did it years ago. But many of the new modern investments just don't need this to be part of the equation here. You want to consult your manufacturer if you're deviating from the instructions of the burnout. Make sure, especially for those of you who burn overnight or wait till the next day, that you get some good counsel and don't run into issues and problems. Now, Whitmix will give you recommended burnout temperatures. But burnout temperatures really are a joint venture with the alloy or glass manufacturer. We need to get to the temperature that their material responds to best. So you need to check with your glass or your alloy manufacturer for each of the products that you're using to see what burnout temperature, what hold temperature they would like you to use. There is that correlation. So make sure that you don't just rely on your investment manufacturer for that information. You need to correlate the two. All right, here's a few alwayses. Phosphates need to burn out over 1400 degrees. So even if you're using them for your type 3, type 4 gold alloys that are full cast alloys, you still want to burn out at 1400 degrees and then reduce the temperature to the casting temperature. They develop their greatest strength up and over 1400 degrees, and you need that. Gypsum investments are usually, and in my case always, not rapid burnout. So if you're trying to do that and having fractures or blow-ups, that's the reason. Your oven temperatures should not go up faster than 20 to 40 degrees Fahrenheit, which is about 10 to 15 degrees C per minute if you're using slow burnout technique. If you're using rapid burnout technique, of course, it doesn't matter. Even if you're using a staged burnout, you should not go up faster than that 20 to 40 degrees Fahrenheit, even in the second stage. Too rapid a climb can cause fractures and breakage of your investment. If you're using critical patterns inside there, I would slow that down. Maybe 10 to 15 degrees, 3 to 5 C per minute, to make sure that those critical patterns have ample time to burn out, especially plastic implant parts. Now, there is a good way to divest, and there is a wrong way to divest. So here's the wrong way. Don't hit a warm button with a hammer. Many of us use those divesting tools to take metal out of the investment. But if you're smacking a warm button, then the chances of the patterns inside also being warm and distorting as you drive them into the investment is exceptional. What you want to do if you're doing that is to break the investment itself, don't be hitting on the button. You want to quench gold alloy, but only after the glow is gone. You want to be in a position to watch for that orange glow to go away, and then you can quench. Generally speaking, you want to wait until these things are cooled off to break them out. It's just the best way. If you don't, this might be the cause of warping in bridges or warping in single units. It's not a problem with the investment. It's the way that you're handling it afterwards. Now, when you get to pressables, that can be a different story. Make sure you come into contact with the glass button or the sprues when you're cutting off the excess. Those of you that are using econo cutters or diamond discs, if you do that, it causes vibration, which may very well be the source of the cracks that you're seeing in your pressed glass. I would use glass beads only, especially if you're hand divesting. Now I know a lot of you like to use aluminum oxide beads, but the glass beads are less abrasive and they are going to hurt the glass pressed margins less. So while you may very well be instructed to use the aluminum oxide afterward to take off reaction layers, while you're getting rid of the investment, I would stick to the glass beads. And then you don't want to recycle glass beads. Once you've used them, they're no longer a bead. Now they are a flying shard of glass. And also, they're not very clean anymore. We still have the chemistry that's left over from the investment and mixed in with them, as well as silica sand that came from the investments. Now you're not really shooting glass beads. You're shooting all kinds of things on your castings and pressings. So please don't recycle those, just like you wouldn't recycle aluminum oxide. Let's talk about some troubleshooting. Pressure vessels, they've come on in the last few years. Many are using them and using them with success to help control bubbles. and this is good, but they can also be a hindrance, so they're a help or a hindrance. You should be using low pressure. When I say low, I mean somewhere down around 30 psi. You only need to really have them in there for about 1 minute. That's plenty of time to press any bubbles out of the way. Then at that point you want to bleed the pressure off slowly. Don't just open it up and shock your systems. You may have problems with expansion if you're putting them in these pressure vessels and then leaving them under pressure while the material is trying to set, because you have two opposing forces. You have the expansion that's trying to take place because of a chemical reaction, and now you have the pressure from the vessel trying to contain it. So if you're having those problems, just using it for a minute, this is long enough to get rid of bubbles, not long enough for the investment to harden, will take care of some of those problems. It also can cause weakening of the investment. If it's left in there too long, that constant pressure like that can break down the binders that hook the molecules together, and you could have weaker investment. So take care when you're using pressure vessels. Now, you also don't want to use worn-out bowls or the same bowls for phosphate and gypsum investments. If you're mixing in these same bowls, that phosphate investment will cause your gypsums to either not harden at all or to increase the setting time. So please use different bowls. The one on the right is good for holding instruments and stuff at the sink and things like that, brushes. But it really is past its time for a mixing procedure. Also, if you've had a decrease in your expansion over time, but you've held your ratios all the same, it may be that your bowl is simply wearing out. When they wear out, the distance between the inside wall of the bowl and the paddle becomes greater and greater. Therefore, the material next to the paddle is actually being mixed more than the material next to the outer wall of the bowl. This causes chemistry problems and leads to lower expansion. I think you'll find that if you simply replace your bowl, you will get your expansion back. Also, please don't use leaking or flat bags. These bags are not vacuum sealed. They do have nice seals on them, but they should appear like the bag on the left with a little bit of a pillow. You should be able to feel the air inside, and the powder material should move freely. Also, if you've got pieces blowing off your ring, similar to the picture on the lower right, or if your rings are simply blowing in half, this is usually a moisture control problem. There's too much moisture left over in the ring. That can be caused by a short bench set. You didn't have a timer on. You thought it sat there for 15 minutes before you put it in, but in reality, it was only there for 11. 11 minutes is not long enough with fast fire materials. And you'll have excess moisture in the ring, and this will be the result. If you're using ringless technique, especially with the plastic type rings that are on the market, then what you want to do is bench set for the required time, then take it out of that plastic or silicone ring and let it bench set another 7 to 10 minutes if it's a 200-gram ring, maybe 3 to 5 if it's a 100-gram ring. This will allow it to blow off the excess moisture that could not escape because it was encased in plastic. I think you're going to find that you'll have better results with your rings if you'll follow that little procedure. I know that it's not in the written procedures at this point, but it certainly will be included later, and we're finding that this is being recommended by not only Whitmix, but some of the other competitive investment manufacturers. Pressing cracks. Generally speaking, folks, these cracks occurred during burnout. They were magnified during the pressing. There's a couple of reasons to this. First of all, that you've got little internal cracks similar to a fin, and now perhaps your ingot wasn't melted quite yet, and you start pressing thick, heavy glass, and it breaks it apart. Sometimes this can also happen if we've got those those cracks, or even sometimes without them, if the bottom of the ring has been ground off at an angle, your press rods, regardless of the company, are coming straight down. That have the press rod push at an angle and fracture rings. But the biggest cause is rings cracking during burnout. So let's go back to the way that we're placing our patterns, the rate of climb in our ovens, and making sure that we're bench setting a proper amount of time. Surface reactions. These can be an investment problem, but rarely are. Generally, this comes from these little tiny bubbles that you see come from the excess use of the bubbleizer. It can also be a reaction to chemicals that are left over on the surface of the wax when you invest. If you're seeing, for example, bubbles inside the crown or coping, but not on the outside surface, this generally we find is a reaction to dilute that's left over. It's time to clean out your dilute bottle. Most of us use it till it gets low, then we simply refill it without cleaning, and this can cause some problems. It also can be caused by a lack of vacuum during mixing, so please check your vacuum machines and make sure that they are running properly. You should be using a standard die, especially when you change from one lot number of investment to another lot number. You want to know what change is going to occur there. If you use a standard die, simply do a wax up, cast it, wax up a coping, cast it, and bring it back to the standard die, and you'll know just by feel if it fits correctly, or if those ratios need to be adjusted to increase or decrease your fit. This standard die, this particular one, is available through Whitmix if you'd like to get that one, but you can certainly use something that can be standardized in your operation. I would walk away from a gypsum die used as a standard because we know that they wear and can change over time. So I would stick with something stainless steel if possible. Now, we get the phone call, I have a bad batch all the time. Batches are created generally in about 1,200 pounds worth of material at a time. And so your one little box, although it could be a bad box, generally speaking, is not a bad batch. What we need to do, though, is find out how to solve the problem that you have. To do that, we're going to ask you if you will call us, give us the lot number, let us do a quick trace, see if we've had any other questions about that. If we've not, then we probably will go through some technique with you, investing technique, mixing technique, ratios, those kinds of things, to see if we can solve the problem. If that doesn't solve the problem, then Whitmix Corporation is happy to replace that investment for you. But we would ask that you return some of the old investment to us for further testing. We will call you back afterwards and let you know what our test results were. I have to tell you, though, that about 95% of the time we cannot get the investment to behave the same way it does in the customer's hand. Part of the reason, I fully believe, is simply because our facility here is controlled. The environment is controlled. Everything is done very precisely here, and that, I believe, is the variation that we get, is that variability in the individual laboratories. Now, if you want to have something in your hands that you can review and go to, if you'll go to our website, www.whitmix.com, you can find there a piece of literature called Troubleshooting Phosphate Bonded Investments. To get to that, you will click on your investment that you're using, or if you're not using one of the Whitmix investments, you can select one of them, one of the phosphates, and then click on Technical Support when that comes up, and you'll find a PDF for Troubleshooting Phosphate Bonded Investments there for your use. Now, remember, too, when you've got problems like this in the laboratory, please use a calm path to find those answers. We want you to call us. Don't wait for 3 or 4 months or 3 or 4 weeks having problems. Please get on the phone with us as soon as you've been able to replicate a problem, and let's talk. There are at least 2 certified dental technicians that are here, in our technical support group. Plus, we've got other CDTs here in employ at Whip Mix to help you with those issues, and some very well-trained other people. So please hop on the phone, let us know what the problem is, and let us help you repair that. Call us. You will need that batch number. Once again, that is on the box that it came in or on the individual packages. It's a 9-digit number. We'll have you work through it with technical support. And please remember this, it does not matter how long you've been doing this. People and conditions change, even when you think you don't. All right, now for those of you that are certified dental technicians and need CE units, within the next 24 to 48 hours, you will be receiving an email with instructions on taking the quiz for this webinar. And I expect all of you to get 100%. And then we will turn in your information to the National Board so that you will have those CE units. Thank you very much for attending this presentation. If you have any questions about it, please do call us at Whip Mix at the 800 number and ask for technical support, and we're happy to discuss further anything that we've talked about today. At this point, I'll turn it back over to Jamie.
Thank you so much, Craig. We appreciate all your help, and I know we're running a few minutes over. At this point, I don't actually have any questions, so if anybody has a question that they'd like to send over, we'll certainly be willing to hang around for a few more minutes and address that. But with not having any here, again, I also want to thank you for your participation. Any feedback that you would like to leave for us would be fantastic. Craig's email address is down at the bottom. We also have the 800 number that you're more than welcome to call us at any time. If you press 2 once you dial the 800 number, that will take you directly to a person. I know how much we all like to avoid the automated system, so we're going to try to help you with that by using the number 2 button when you dial the 800 number. We did have a question just come in, Craig, and so I'll kind of turn it back over to you. One of the participants asked, how do you warm investment powder?
Well, there's a couple of 3 ways, but I found in my small laboratory that I had, the easiest way was just to put the package on top of my porcelain furnace. That was sufficient temperature to warm that up. You can use warming trays if you happen to have one. They're available at big box stores like Walmart that'll warm things up to a good temperature. You can drop it if it's winter time. You can drop it on top of your heater vent and let the warm air that's coming out of there warm it up. Any of those ways. I would not suggest using a Bunsen burner. That might be a little difficult and not very consistent. But something similar to that, and that will get you going. It doesn't have to be too warm. It's got to be just up past room temperature, so somewhere up around 100 degrees at the most.
So there we go. We don't need a whole lot of sophistication. It sounds like we've got a couple of different options for us. We have another question that just came in here. To alleviate, the question is, and there's kind of a comment and a question, to alleviate the cracking of copings for direct spruing, should we just make the sprues longer?
Yeah, that actually helps quite a bit. You'll notice, maybe you remember in some of the presentation pictures, some of those sprues were really long. We generally here at Whip Mix won't use a 60-gram ring. Those were designed for inlays and using inlay investment, which most of us have walked away from. So we're using 100-gram rings almost every time. You can do a direct sprue and sprue it to the top of the top and the outside, right, high and outside in the ring, and you'll find with that and and just a relatively nominal button at the bottom that you'll get a lot better result in your spruing. Now, if it's non-precious alloy, of course, you've got a little bit of an alloy waste there, but you've got a lot of time with a cracked investment, fins, distortion, in your own time and energy costs, plus the cost of material to redo it. So for non-precious alloy, I don't think that's too much of a waste. For gold alloys, you're going to use that material over again. The only thing is that you're going to need to be adding new alloy now and then to replace some of those trace elements that get burned off. So you may have to separate a button here and there to add, and then add new ingots.
All right. Well, hopefully we've answered your questions. If you have any other questions, again, feel free to use the question tab. You know, we're over a little bit, but we'll be on for a couple more minutes. I also wanted to just kind of let folks know we do have a couple of additional webinars, of course, free as this one, and you can earn CD credits coming up. In October, we've got Lean for the Lab webinar that was very popular the first time we put it on. Bob Long will be showing you some of the techniques and some of the activities that you can do to start to make your lab and the functions of it more lean and speed up your process. And then we're also going to be doing, towards the end of the month, a technician's guide to the Pro Series furnace. And this is for both the Pro 100 and 200 series furnace. We talked quite a bit about, you know, pressing, Emacs, the other lithium disilicates, you know, a little bit about porcelain, and really some of the features and benefits of the Pro 100 and 200 series products, and some of the tips and tricks that we've learned along the way. We have one more question that came in for you, Craig. What generally causes fins in the crown and bridge metal?
Well, the biggest reason is patterns that are too close together, or patterns that are all in the same horizontal or vertical plane, usually a vertical plane. So you want to separate your patterns. So if you're using indirect technique, where you are using a bar, then instead of stacking your patterns directly on top of the bar, lean them out away from the bar, away from the center and toward the outside edge. If you have multiple patterns, you can switch back and forth on them, if you understand what I mean there. So that if, well, take your two index fingers, put them together so they make an X. If the bottom of the X, where both your fingers cross, is your runner bar, looking at it from the end, then your pattern should be out on the ends of the X's, okay, not straight up and down, and that will decrease the likelihood of thinning.
All right. Well, again, we appreciate your participation. If you have any other questions, our 800 number is listed there. Craig's email is also listed there. Feel free to send us, you know, comments, suggestions, any other questions that you have, and don't forget to visit our website, www.whipmix.com. There's a full list of other webinars that are coming up, along with you know, plenty of product information and technical support. And if you can't find it there, don't hesitate to call us. Thank you so much for your participation, and we look forward to seeing you out in the field or at other webinars. Have a great day.